Welcome to a tutorial on scaling your Jet10 design down to a more manageable set of dimensions for your hand-built glider. For lessons 32 and 33, we're going to be doing a glider build and fly. This is designed to be a more fun and relaxing lecture, although there's a little bit of stress getting your product complete. There's going to be some arts and crafts and a little bit of mathematics, so I hope you get something out of it. But we'll start in 5J12 with your scaled down dimensions. Make sure you bring at least your laptop and your list of sizes after you've watched this tutorial. For that day on lesson 32, please wear your OCPs. We'll meet back in 5J12 for lesson 33, but we'll head to F1 for flying. And of course, you have to wear your flight suits. Where are we going? Well, this is what your final product's going to look like. From left to right, you kind of see the Depron foam we're going to use, a large printout of a design, and then the final product. And it's a rough two-dimensional representation of your aircraft, but it tends to fly pretty well, actually. So you're going to be building one of these. To scale down from your Jet10 design, which is representative of an actual aircraft, you're going to have to use some sort of scaling factor. You're going to rely heavily on the geometry, and I'm going to provide you a scale to use. Don't forget your equations from wing and whole aircraft lessons, in particular aspect ratio, plan form area, taper ratio, etc. You might even need to throw some trig in there. Don't forget your SOHCAHTOA. So for our purposes, you're going to use a scaling factor of 1/24. That means your dimensions, once they're scaled down, cannot exceed a 30-inch length fuselage, because that's the limit of the foam size. So you can't have a bigger airplane than the foam that we have. So I'll give you an example. If you have a 48-foot wingspan in Jet10, the first thing I would suggest you do is convert it to inches and then divide that by 24. And those are the dimensions you'll bring in and physically measure out onto the foam for your glider. Where can you get some of those dimensions? Well, on the Geometry tab of Jet10, the tip chord and span are calculated for you for each of the surfaces. Don't forget all the geometry you've been entering into the main tab. Once you have wing area and aspect ratio, you can calculate the span. You'll need to grab the tilt and or dihedral angles. You'll need the fuselage length. And don't forget the widths of each of the cross-sectional sections of the fuselage. Now, it's not going to be as important when you get to the wing section, because once you have the wing span, that will include the fuselage, but up near the nose and the very tail, you'll certainly need some sort of width to convert down to. So for the wing strakes and tail sections, you'll need a span, tip chord, leading and trailing edge sweeps, and or tilt or dihedral. You'll need to have the separate dimensions for the tail, because you have to cut that and mount it separately. Finally, for the fuselage, you need the length from nose to back. And of course, as I mentioned earlier, the various widths, especially at the nose where the wing sections aren't present. So here's an example of what a rough sketch might start to look like. This is just a sample. But you'll print out your design and start to transfer your measurements on here so you can transfer them to the foam once you get to the building day on lesson 32. Finally, this is what your final product is going to look like. The wing strakes fuselage will be one flat piece of foam. There'll be a balsa wood stick glued to the bottom, sort of act as a spine, as a stiffening device, and has some other features. But the vertical tails are going to be cut separately and then glued onto the top. That's the end of the tutorial. Please watch the full-length video that I've also produced to highlight how you can go about some of the manufacturing techniques to cut a better glider.